So our next skill is, can we take something in vertex form, graph it, and it's easier to graph if you know this information. So the first thing is identifying the vertex. And I see that because this is -3, the vertex will be at +3. And because this is 2, I also put 2 down here. So I just found the vertex is at 3, 2. So what that means is, over here at 3, 2, I have the vertex. That also means that I have what's called an axis of symmetry, and the axis of symmetry will be at x equals 3. And what that means is you just basically have this line of symmetry and we call it the axis of symmetry. And so whatever happens on the left side happens on the right side. So for example, if I were to put this point right here, then I would put this point here. That's what the axis of symmetry means. Or if I were to put a point right here, then I would also put one here. It's symmetrical. That's what axis of symmetry is. Now you can't just make up points. You have to take the function in hand. And the first thing I want you to know is, does this open up or down? In other words, does it open up? This is what we call up. Or does it open down? It's one or the other. It either opens up or it opens down. How do you know? Well, you go out here and you look at this number out front, and it's a 1. So if it's positive, then it looks like this. If that was a -1, then it would be this one. So I just found that it opens up. And because it opens up, that means that right here, the vertex, would be what we call a minimum. It's the smallest value. Had it look like this, I'd call it a maximum. Now, what is that max or min value? Remember, we just said it's a min. That value is this number. So my min value is 2. So the lowest this graph will ever get is 2. It'll never be down here. Now we need to start filling in the graph, and the first thing they ask for is the x-intercept. First thing they ask for is the y-intercept. So when the y-intercept means that x is 0. So instead of putting an x, I'm going to put in a 0 and see what I get. And that'll tell me the y-intercept. 0 minus 3 is -3. -3 squared is 9. 9 plus 2, I'd get 11. So I just found that my y-intercept is at 0, 11. What that means is up here at 11, I have a y-intercept. About right there. It doesn't really fit on the graph. So what that means is 1, 2, 3, I could also go this way, 1, 2, 3, because that's symmetrical. The other point's going to be right about there. Now this one didn't really fit on the graph, so it's not really a good point to pick. But now let's try 2. Let's plug in a 2 and see what we get. So now when I plug in a 2, two minus 3 is -1. -1 squared is 1. 1 plus 2 would be 3. So I just found that if you plug in x is 2, you get back 3. So what does that mean? That means that over here at 2, you have the point 2, 3. Because it's symmetrical, it'll also be here. So if I were to plug 4 into this function, I would also get back 3. Now let's try plugging in 1. If I plug 1 in here, what will the value of y be? 1 minus 3 is -2. -2 squared is 4. 4 plus 2, I get 6. So I just found when x is 1, y is 6. So that means when x is 5, y is also 6. It's symmetrical. Now I have enough information to graph my parabola. And it's going to start up here. It's going to come down, reach the minimum, and then go back up. And this isn't the prettiest graph, but it'll work. But this goes up forever. To check my work, what I could do is I could plug this in, x minus 3 squared plus 2. And just look, okay, the vertex is at 3, 2. It looks like that. The y-intercept is 11. Does mine look like that? Yes. Not exactly, because I could spend a little more time drawing this next time, but for the most part it's the same. If someone asked me what the x-intercepts were, I would say no real solution, or I could find them in the imaginary number system.